Hello, geometry. We are jumping into the 9.3 notes. I hope your day is going fantastic. Thank you for watching. Thanks for tuning in. I appreciate you. We're looking at spheres. We're looking at spheres. So we had some prisms and we had some pyramids, but now we're looking at spheres and hemispheres and stuff like that. So we have our two lovely formulas for surface area and for volume. So remember, the space inside. So we're going to find the surface area and volume of each of these spheres. So surface area is 4 pi r squared. So I see that the radius of our sphere is 7. So this is going to be 4 times pi times 7 squared, which equals, I'm just going to plug that straight into a calculator because why not, right? So bring up a calculator on my end, and we've got 4 times pi. 7 squared is 49, so 4 times pi times 49 gives me 615.8. And because this is surface area, that's going to be inches squared. And when we do volume, it is 4/3 times pi times radius cubed. And 7 cubed is 343 times pi times 4 divided by 3. So I know some of us get a little scared or intimidated or a little confused on how to punch these things into a calculator sometimes, especially when we see fractions and whatnot. It's okay to punch these things in separately. I've got on my screen here 7 cubed. I'm not even doing the 4/3 part first because I'm just going to do the parts that I know how to do. 7 cubed, hit equals. Okay, there's that big number. Times pi, okay, hit equals. There's that number. And then it says times 4/3. Well, when it says times 4/3, the numerator is always multiplication and the denominator is division. When you have a denominator, that means you're dividing by 3. And there's my answer. Let's do it one more time here, the one below. You can see here that it's given us the diameter, so our radius is going to be 6 this time around, but everything else is going to stay the same. When I plug it into my formula, I'm squaring my radius, and when I plug it into this formula, I am cubing my radius. And when I plug each of these into the calculator, 6 squared is 36. Times pi times 4 is 452.4. And then we've got 6 cubed. I don't know what that is offhand. 6 cubed is 216. Times pi times 4 divided by 3 gives me 904.8. This is centimeters squared for surface area, centimeters cubed for volume. So if you would, real quick, let's have some answers pop up on screen for surface area of letter B here. So you've got that 4 centimeters. Is that the radius or diameter? Go ahead and plug that into the formula and some answers pop up on screen. And then if you would also do the same, you've got that 4 centimeters, and now let's find the volume. Some answers pop up on screen. So what did you do for them? Is that 4 centimeters the radius or the diameter? It is the radius. So you did 4 times pi times and we'll plug that into a calculator in a second. And this one is 4/3 times pi times 4 cubed. And when I plug each of these into the calculator, I get 4 times pi times 16, 4 squared, 201.1 centimeters squared. And then 4/3, so 4 cubed is 64 times pi times 4 divided by 3 gives me 268.1 centimeters cubed. I'm going to go ahead and leave that last one blank. Do we really need to do it one more time? Probably not. You have a beach ball with alternating red and blue stripes with red caps at the top and bottom. If 55% of the beach ball is covered in red, then what is the approximate surface area of the ball that is red? So, how do you take 55% of something? How do you take 55% of something, right? How do we accomplish that math? Well, you multiply by 0.55 because that is 55% as a decimal, right? You were taught at some point in your life to move the decimal 2 places to change your percentage into a decimal, right? Okay, I don't know if you could tell, but I paused it there for a second. So we take 55%, 0.55. So if we can find the surface area of the entire ball or the volume of the entire ball, whichever, right? And if only 55% of it is being used, then you multiply by 0.55 to find 55%. And 0.45 for 45%, 0.35 for 35%. You get the point. So if we're talking about the red, it says surface area here. We're not using volume. The ball, the surface that you can touch, the red surface, that's, well, the surface. So we should use surface area, which is 4 pi r squared. So the total surface area is 4 times pi times, the radius is 14 inches. It says it right there. So I don't know what 14 squared is. 14 times 14 is 196 times pi times 4. So the total surface area is approximately 2,463 point blah, blah, blah. Please, 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 please listen to me right now. Leave that in your calculator. Do not round it. Just leave it. It's right there. It's like in your calculator already. Like there's no need to there's no need to round. There's no need to write it down. Just leave it. And now we want to take 55% of that. So we multiply it by 0.55. And we get 1,354.7, and this is inches, so inches squared. Now, had you rounded it, right? If you go back to what did it say? What was our decimal? What would you have rounded that to? You probably would have rounded it to 2463, and that's it. Maybe you would have done 0.01, 2463.01. Maybe you would have done that. And when you multiplied it by 0.55, the decimal is different here. The decimal is different, especially had you left it like this, which some of you might have, right? The decimal is coming out differently, and I don't want you to round mistakenly. I don't want you to make a rounding mistake. We want to leave it in. Sometimes you get lucky, and the rounding is the same. Sometimes you don't get lucky, and the rounding is different. So please, please, please leave it in your calculator. Okay. What is the approximate volume of the beach ball? Well, there's really no tricks up our sleeve here. Just 4/3 pi r cubed once again. So 4/3 times pi times 14 cubed. 14 cubed, that's a rather big number, times pi times 4 divided by 3 gives me, geez, oh Pete, 11,494.04 inches cubed. That seems like such a big number, right? But it's true. It's true. Okay, so When it comes to some application with volume, like why do we care about volume? Volume is a big component of density. Remember when we talked about population density? I brought up density back then, even though it was only about population density. I brought up density and I told you DMV. Remember that? All right, I brought up DMV and I made a triangle. This was population density. This was the amount of people, and this was the size of the state, right? Do you remember that? DMV. So you look at this triangle. Density is found by doing mass divided by volume. Or you can look at it the other way around and say that volume equals mass divided by density. Or if you're trying to find mass, you do density times volume. You see how this triangle helps us figure that out? M over D equals V. D equals M over V. And M equals D times V. So there's that. So if we're trying to solve one of these problems, a ball of lead has an approximate radius of 2.1 centimeters and has a mass of 440 grams. What is the approximate density of lead? How about you do a little something for me? How about you solve for the volume of this ball? So if you have this ball of lead, this sphere of lead with a radius, that's a terrible drawing, with a radius of 2.1 centimeters, I'd like you to solve for the volume. Some answers pop up on screen. So if you're solving for volume, you used 4/3 pi r cubed. So that's what you plugged into your calculator. And I had some answers for you there on screen. So 2.1 cubed times pi times 4 divided by 3. And I probably rounded a little bit for you just to make the answer choices easier. We'll call it an approximate 38.8. Now, what is the density of this ball of lead? Well, if we know the mass is 440 grams and we know the volume is 38.8, well, then we can get our answer. But as I said earlier, please do not round in the middle of your problem. It is that's a bad habit to get into. So let me show you on my calculator what I like to do. This is the long gibberish answer that I got, right? I'm going to do 440 divided by that answer. And there's a reason I use the Google calculator, or I use, a nice scientific calculator. And there's a reason your iPhone calculator is garbage, okay? iPhone calculators are literal garbage. There's a reason people download calculator apps on the iPhone. There's a reason the iPad doesn't have a calculator on it. It's because they know their calculator is garbage. So please use a better calculator. And look, the answer, it's right here. You can see. So I'm about to divide by that previous answer, and I get 11.34. Had you rounded and used 38.8, I'm curious, would we have gotten lucky? Sometimes you get lucky. We would have gotten lucky. 11.34. But sometimes, look, it was on the verge of saying 11.33. It was on, look at that 0 right after. It's so close to saying 11.33. Okay? I can guarantee that every once in a while you're going to get marked wrong if you start rounding like a maniac, okay? And let's take a look at this last problem here before this table. We'll fill in this table together here. Two logs of different types of wood are approximately cylinders. Use the data in the table to compute the density of each of the woods. So they are cylinders. So volume isn't something that's exclusive to spheres. I know the focus of this lesson has been spheres so far, but you can calculate density for things other than spheres. So there's a cylindrical piece of wood, aka a log, one of them being oak, one of them being balsa, and one of them has a diameter of 4, one of them has a diameter of 2. The height of the log is 7, the height of the log is 10. So if we want to compare the densities of each of these, we need to find the volume of each of these. So volume is area of the base times height, okay? Because these aren't spheres anymore. We're not using the formulas from on the first page. We're going back to lesson 2. So what is the area of this circle? That's pi r squared. The diameter is 4, the radius is 2, so that's 4 pi times 7. So the volume is 28 pi. And this 2 cut in half is simply a 1. So 1 squared is simply 1. So that's not doing anything. So the area is pi, and then you multiply it by the height, and you get 10 pi for the volume. This is oak. This is balsa. If I did that too quick, back it up and watch me do it again, or go back to lesson 9.2 if you were thoroughly confused. But there's our volumes for each of those. And density is mass, 37.4 ounces divided by volume. And density is mass, 5.1 ounces divided by volume, 10 pi. So what are the answers that I get here? 37.4 divided by 28 pi is 0.43, and density is ounces per inches cubed here. I forgot to write my units on this one. This was grams per centimeters cubed, because we have ounces on top and we have our inches on bottom, right? So ounces per inches cubed. And the second one is 5.1 divided by 10 pi, and I get 0.16. So again, to remind you of what density is here, it is a measurement of how filled something is, how much stuff is inside of a thing, I think was what I said, right? Remember when I said that? So there's more stuff inside of oak versus balsa. And if you know anything about wood, you know that oak is a pretty sturdy, strong wood. It's very heavy. And yeah, it's because it's more dense. And balsa, I don't actually... What do they make with balsa? I know furniture is made with oak. I don't know what they make with balsa wood, but it's definitely weaker, okay? You could probably crack a 2x4 of balsa but over your knee, but maybe not oak. You might break your kneecap. Okay, I'm not trying to make this go too long here. So let's just look at this table. It's just some extra practice here for finding volume and density. I'm going to speed up the process here by pausing. Okay, so real quick, I found the volume of each of these. Area of the base times the height. Area of the base times the height divided by 3 for a pyramid, and sphere was 4/3 pi r cubed. I found those very quickly. And then density here is just mass divided by volume. Mass divided by volume. Mass divided by volume. So to save you some time real quick, I'm going to do that as well. Okay, so I went ahead and found all of those. Mass divided by volume, mass divided by volume, mass divided by volume, and we have the density. Now, what's the significance of this, and what's the significance of all of this down here? Well, here's the thing. Materials, I don't mean to drone on too long here, but this is kind of cool here at the very end. It's an interesting little thing. Materials have specific density, okay, that is unique to that, right? If you grab salt or sand or cork or chalk, no matter what chalk you buy, no matter what cork inside of a wine bottle, no matter what salt you buy, it has a unique density. Now, obviously, you could alter it somehow, right, by performing some sort of, manipulation. But at its core, just plain old salt has a specific density. Okay, it has a unique density. So if you're given a rectangular prism, like a little block of some sort of thing, right, we can identify, like, we don't know what this little prism is made out of, right? Someone hands you a rectangular stone and you're like, what is this? And the person's like, you figure it out. So we found the density of this little stone and we go, well, if the density is 0.917, you know what? It looks like they handed me ice. Now, obviously, I could probably tell what ice is if someone handed me an ice cube. But the thing is, if we were blind, ice, we would identify that as ice. Someone hands you a little pyramid, right? Like it's this little crafted pyramid, right? It's smooth to the touch, and you're like, oh, what is this made out of? Well, you figure it out. The density is 2.802. That makes me think that, oh, this square pyramid is made out of sand, right? Maybe it's hardened sand. That would be kind of cool. You get the point, is that if you know the density of the object, you can cross-reference this to this table to figure out what it is. So the very last one, what is the sphere? What is this little ball made out of? That the density is 0.250. That means it's made out of... I don't see it. Oh, it's a little cork ball. Okay. And with that, I suppose I bid you adieu. I shall see you in class, and enjoy your day.